Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes way. Don't delay and enroll now.
Geeks learning together.
Hello guys and welcome back to this amazing channel Geeks for Geeks Practice. This is Abhinav and today we are back with our next problem of the day, which is nothing but Geeks, Village and Wells. So guys, the problem says that it's basically a problem based on the BFS technicograph. So first of all, please let me know if I'm clearly audible and visible to you all so that we can start the class. Please let me know if I'm clearly audible and visible. Okay, great. So I hope that my screen is also visible to you all. Let's see the problem. So guys, the problem says Geeks, Village and Wells. So guys, it's a problem which is something similar to the problem called a number of provinces or number of islands in Geeks for Geeks. It's There's a 2D matrix given to you. Okay, there's a 2D matrix given to you. There's a 2D matrix given to you. Okay, so what we have to do is that H represents a house, W represents a well, dot represents an open ground, and N represents prohibited area. So what you have to do is that for every house in that matrix, you have to find the nearest well or the nearest water to it. Okay, and you have to count the distance like at both the side. What you can do, you can travel either left, right, up and down. Okay, and for wherever there's a prohibited area or a well or a dot, for that particular thing the answer will be zero. And for all the houses only wherever the h is there, you have to find the answer. Let's understand what they are saying. So let's say that the first example that is given to you is like this. There's a house, well, house, house, house. So means in your answer matrix for this well, your answer will be zero because it's the well only. Okay, water is there only. But for all the other houses, you have to find it. Guys, just give me 1 minute. Am I audible now, guys? Am I audible now? Okay, there was just a problem actually in my laptop. I hope it's now fine. Okay, great. So that's the problem. You can see, guys, for this house, the first house, the distance is 4. Why? Because from here you will first go here, then down, and then again you have to go back. So distance is 4. Okay. Similarly, guys, if you will see for this particular house, the distance is 2. You will go to well and you will come back. Distance is 2. Similarly, guys, all the distances of the houses are measured. And you can see that is how the distance is output. Okay. Similarly, you can see in the next part, guys, what is happening here. You can see in this particular case, this is the house. So this house cannot get water. Why? Because this house is surrounded by all the prohibited area. 1, 2, 3. That is why for this house, answer is -1. And guys, wherever there is a n, there is a w, or there is a dot. In all that places, your value will be 0. For houses only, you have to find the thing. Got it? Great. So now let's write a BFS solution for it, which will be executed using Q. Okay. So as we have to store the answer in a like 2D vector, what I will do here is that I will take a 2D vector. Okay, which will be nothing but, let's say, result. Okay, vector result, where we will store the result. The size will be equal to the size of the matrix which is given to, which is n comma n. So the size of this vector will also be equal to the size of the matrix which is given to you. And guys, initially what I will do, I will make all the values of this vector as infinite or a very big value, because you have to find the minimum. So I will initialize it with a very big value and I will give it minimum. Okay. Now, guys, what I will do, for every index where there is a water, okay, where there is a water, what we will do, guys, for every index where there is a water, we will be giving that index value 0, because if the water is present there, we'll give it 0. And at all those index, okay, and at all those indexes, we will apply the BFS, so that we can go from there and we can calculate for the other values. Okay, so we will calculate distance for the one side only, and then we will double the distance. So what I will do, I will iterate first of all for all the values of I comma j. Okay, for all value I comma j, and if that value, like this is that c given to us, if that value c of I comma j is a water, if it is a water, so I will take a q here, because I have to put a BFS. If you remember, for implementing BFS, that's a prerequisite problem. What we do, we take a q of pairs. Okay, and guys, in this particular q, I will push that value. I will push that value. And then I will also make the answer for that particular value at 0. Why it should be 0? Because well is present at the index, so the answer will always be 0. Now, guys, what we will do is that I will now iterate. So as you know, if you know the BFS algorithm, there is a queue which we have haven't. And let's say in this queue currently we have the index number 1, 1, because that's the water here. Okay. Now for this index, I will apply a BFS algorithm. Okay. So like while my queue is not empty, so yq dot empty, yq is not empty actually. Okay, what I will do, so while queue is not empty, I will first take the front of the queue. Okay, so let's say I'm taking a pair here of int comma n, as we know that the front is pair. Okay, pair p, got it? And if here I have the front of the queue, now I will pop that front. Now for that particular front, we will apply our BFS. So I will take the current values of this front. So like every front have a I and a j. Let's call it ij, let's call it xy, whatever. So I will have a current x, that will be p dot first. Okay, and I will have a current y, that will be nothing but p dot second. That will be nothing but p dot second. So I will have a p dot first and I will have a p dot second. Got it? Now, guys, what I will do now from this particular index, let's say we are at index number 1, comma 1. So for this particular index 1, comma 1, I have four options. Which four options are there? Like from here, I can go here, 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 or here. So I will check for all the four options. I will check for all the four options. So for that, we can like have a vector for it. We can have a we call destination vector, something like that. So we'll have like this dx of size 4, because you can see we can go up. Up means that your index will be increased by 1. Okay, or I can say if you are going up, let's say if you are at I comma j, let's say you are at I comma j. So when you are going up, it means I minus 1 comma j. When you're going down, I plus 1 comma j. Here, I comma j minus 1 and I comma j plus 1. These are the four things that we're having. Okay. So guys, what we will have is we'll have 0, 0, minus 1 and 1. And similarly, for their opposite, for a dy, 0, comma 1, 0, comma minus 1, 0, comma 0. So all the four combinations we have taken. Now for these four combinations, I will check for the BFS. So I will have these four in the loop. I will have these four in the loop. And then I will check the index of that particular index. So let's say it's x is equal to current x plus that particular displacement. This is the displacement vector we call it. So we'll take that particular displacement vector at I, and the same will be done for y also. The same will be done for y also. Okay. Now, guys, before checking, we'll also check one thing: if this x and y are in range, like if this x is greater than or equal to n and less than n, and I will say if this y is greater than or equal to 0 and less than n. So if all these things are cleared, if all these things are taken, in that particular case, what I will do is I will check if the current index where we are, because we have to also check, like let's say if I'm going from this house to above to up, let's say, so I have to also check that house should not be a prohibited area. That should also not be a prohibited area. So I will also check that thing. So if that is not a prohibited area, and guys, and the current value at that house, because there will be a current value of that house, if that value is greater than the current value, because what will happen, guys, let's say I will explain you, just give me 1 minute. Now see one thing, guys, why I have written this thing. So let's say, guys, for that particular point, currently my value is infinite, or let's say 10 to the power 9, and I'm going from here. So when I'm going from this well to this house, I will take one step now. So number of steps till this house, plus 1 will be given to me. So I'm taking number of distance for this house plus 1 is given. And if the current distance of that x comma y is greater than it, and we want minimum, we don't want greater. So if it is greater, so I will make it equal to this. And then as I have calculated for that particular value also x comma y, I will push it that x comma y also into this. And this will go on. This process will go on. And guys, at the last, when this while loop will stop, then at the last we will check that for all the indexes, see guys, for all the indexes, I will iterate. And the thing is that if my point is there, as I told you, if my character is a dot, that means it's a plane area. That means my answer should be 0. We know this thing. Now, else if, what if that particular area is not reachable? So guys, if that particular area is not reachable, so there can be two ways. There can be two options if they are not reachable. So let's say first of all, if that particular area is still equal to 10 to the power 9, that has two meaning. Either character of that is not equal to n. If character at that particular index is also not equal to n, if it is not equal to n, that means it should be equal to wall or house basically. If it is not equal to n, that means it will be equal to house. And if it is not possible to reach a house, that means our value will be minus minus. And else if it is not equal to house, that means it's a prohibited area. In that case, if it's a prohibited area, so obviously they are saying that for a prohibited area or for any area apart from the house, we have to make it 0. Okay. And else guys, else means if everything is fine, it's also not a doubt, it's also not a not possible area. Simply, as they are saying, you can see here in the problem, they are saying you have to count distance for both. Okay, one should travel to take out the water and carry back to house. You want both the distances, na? Go and come back. Okay, yeah, thanks. Yeah, thanks. Okay, so you want both the things. So because you want both the distances, you will multiply your current value by rate, rate, and then guys, we will simply at the last return our. So let's run this code. I hope it should be fine. It's taking time. Okay, it's evaluated. Let's submit it. Okay, so guys, the code is submitted. Okay, so guys, this is how we are solving this particular problem. It's a basic code. So if you, I will recommend you two more questions. First is number of provinces. Okay, and second is number of islands. So guys, these are two more problems that I will recommend you guys. The first is number of provinces and number of islands, which are also somehow similar to this problem, and even they are easy. This one has some more, as you can see, constants like house is also there, well is also there. There are multiple constants in this problem. Okay, so if you are having difficulty in solving this problem, the first thing is that you have to have a revision of BFS, that how BFS is performed, and then you can solve these two problems, which are a basic example of this particular approach. And if they are done, then you can like also focus on this problem called Geeks. Okay, great. So I hope guys you have got this particular video, this solution. Uh, Thank you. Okay, great guys. Let's meet again tomorrow with the next problem of the day. Till then, thank you. Bye bye. Happy coding. GFG कर लो हो जाएगा.